Welcome to Chapter 5 on Hazard Analysis and Preventive Control Determination. So in this chapter, we are going to be conducting a hazard analysis. So we'll look at the components of a hazard analysis and kind of that decision-making process that goes along with the hazard analysis itself. And at the end of a hazard analysis, we should be able to say whether we need a preventive control or not. So that's that piece on preventive control determination. Here's our objectives for this chapter. We are going to learn how to conduct a hazard analysis. Okay, that's kind of our first focus of this chapter, conducting the hazard analysis itself and how we actually analyze the hazards. Remember, this is really similar to other risk assessments that you may have been involved in, but we'll get there in good time. We're going to look at how we determine whether hazards need a preventive control or not, and we'll also be identifying and talking about some of the resources that might help us figure out this process and make those decisions. These resources aren't going to be exhaustive lists. You may have some other resources that you're already using. Continue to use those as long as they are valuable resources for you, but if you're looking for some more to add to your list, we can talk about some of those resources that are available. Okay, let's jump right into the regulation here. So here we are at 507.33. Now, in an earlier chapter, I believe it was chapter 3, I read you parts A and B of 507.33, which essentially said that we have to do a hazard analysis and we have to write it down. Now, this gets into a little bit more of the specifics about what's going to actually be in that hazard analysis. The first thing that we need to include is going to be a list of the known or reasonably foreseeable hazards that fall into that category of biological, chemical, and physical. So we talked about all of that in chapter 3. So our first step is going to be identifying the hazards. Number 1, making the list of known or reasonably foreseeable hazards. Number 2 is going to be evaluating those hazards. So here's your evaluation of. And to evaluate any hazard, what I need to evaluate it for is its severity and its probability. So how severe is it? If it does get into my final product, is it going to cause death or is it going to cause just diarrhea for an hour? Okay, very different severity levels. Probability, how likely is it that it is going to get into my final product? Okay, so we've made our list. On each of those hazards, we're going to evaluate for severity and probability. Now, if you have animal food that is exposed prior to package, so it's finished animal feed exposed prior to packaging, and you have an environmental pathogen, you definitely need to make sure that you include that in your hazard evaluation. So if we know we have an established environmental pathogen, that's going to increase the probability of that hazard getting into our final product versus a situation if we didn't have that established microorganism. Okay, the hazard evaluation should consider all of these things. So this should be a very methodical process of doing your hazard analysis. This is just a kind of a short list of things that can help us in this process. So we need to consider the formulation of the animal food, the condition, function, and design of the facility and equipment, any raw materials and other ingredients. This is a lot of times how we get hazards in our facility, right? Is with our raw ingredients, and then we're going to process them to control it. Any transportation practices, manufacturing or processing procedures can introduce or increase the likelihood of hazards. Packaging activities, labeling activities, storage and distribution, intended or reasonably foreseeable use, any sanitation procedures, including employee hygiene. Again, another common way that hazards get in through employee hygiene or human error. And any other relevant factors. And this mentions temporal factors, so that's specifically referencing mycotoxins, where the likelihood of that hazard occurring can be affected by the growing conditions and the weather conditions that it was grown in. So that kind of thing can be taken into account when we're doing our hazard analysis as well, especially when we're considering that probability factor. Okay, so this is just meant to be a list of things that we can consider when we're doing our hazard analysis. This is a graphic that we will see a couple of times in the next few chapters. This is meant to help you visualize this whole hazard analysis process. So up here, all of these circles are everything ever possible in the world, good or bad. We put them through this first funnel right here and ask ourselves, can it cause illness or injury? If the answer is yes, then we call it a hazard. So anything that causes illness or injury is considered a hazard. Then we drop it into the next bucket. If it is a hazard, we drop it into the next bucket and ask ourselves, can it be associated with our facility? Can it be associated with our intended species? And that pops it into this definition of known or reasonably foreseeable within our facility. From there, where we're at right now, so we've seen those two parts before, but this part right here is this third bucket. And in this third bucket, I ask myself, what is the severity and what is the probability? If the severity is medium to high and the probability is medium to high, that's how I know that I've identified particularly high risk situations, and I know that I need to have preventive controls established. Okay? When we consider probability, what we saw in the regulation, let me go back one slide. 2 slides. When we consider probability, check this out right here. Probability that the hazard will occur in the absence of preventive controls. This does not say in the absence of CGMPs. This bucket right here is already considering that we have CGMPs in place. So most of our known or reasonably foreseeable hazards that we identified right here are going to be taken care of with our CGMP program. We're just going to pluck out a couple of very high risk situations and put a preventive control on them because they're high risk, because we need to keep a closer eye on them, because we need to keep paperwork on them, because if something goes wrong with them, it's going to be a much bigger problem than any of our other known or reasonably foreseeable hazards. So even in pet food facilities, this is only going to be a handful of things. Other facilities that are lower risk situations might have one or two or none at all. Okay, but this box right here is kind of where we're living for chapter 5 to help us see how we can make those decisions. So this slide is kind of reiterating some of the things, some of the themes I've already talked a little bit about. So a big idea in this chapter and a big idea in this process is this hazard identification and evaluation is going to be different for every facility. So when we're talking about identifying hazards, we've kind of talked about this in chapter 3, where our intended species, the manufacturing process can all change what's known or reasonably foreseeable in our facility, what can actually be associated with our facility. Okay, from there, now that we've done the identification, the evaluation part can be a little bit different also. So I talked about probability, how we can change probability a little bit already. Remember that probability takes into account your CGMP program. So if you have a very good CGMP program and you're doing documentation and you have history of that CGMP program working, that decreases the probability of a particular hazard happening in your facility. And if we were to compare your facility to a facility that doesn't have very good CGMPs or doesn't monitor any of their CGMPs, that the probability of the hazard happening in that facility is increased because they don't have a good established CGMP program. Okay, so probability is flexible given what's going on in the facility. Severity can also be a little bit flexible, although I think less so. Severity, I think, is mostly flexible when we're talking about the intended species. I like to use metal as an example. So a metal hazard in a Chihuahua food is very different severity than a metal hazard in a finished cattle feed. Okay, we're feeding very different size animals. The severity of of that hazard in those feeds is very different. Okay. However, if we think about like copper in sheep, that's always going to be a high severity. If you're making sheep feed, copper is always going to be a high severity simply because it has a big effect on sheep. Okay, so there's some play in there, and we're going to talk a little bit more about that and look at some examples of that as we go along. This graphic right here is meant to help you visualize the whole hazard analysis process step by step. Again, a very methodical thing. So this is our third bucket broken down into 8 steps here. Step 1 and step 8 are considered optional, but I think they make sense and will help you do the rest of the process. And we're going to go through each of these steps. And I recommend that you get in the habit and get in the practice of taking these steps one by one so that you can make sure that you've got all of your bases covered and that you're doing this all methodically and correctly. So the first one is to list your ingredients or your steps and manufacturing steps. And this one is mostly kind of what I consider like a brainstorm session. So if you start to list out your ingredients and list out your manufacturing processes, that's going to help you do step number 2, which is to identify your hazards. So when we're identifying our hazards, we want to make sure we know what is possible within our facility. So if I have my ingredients, say, oh, one of my ingredients is corn. One of my known or reasonably foreseeable hazards is gonna be mycotoxins. That's just the nature of the beast there. If I'm using metal equipment, in my manufacturing process, I know that one of my hazards is going to be metal pieces or bolts falling off, whatever that might be. Okay, so step number 1 was to list out the things that's going on in your facility. Step number 2 is to make your list of known or reasonably foreseeable hazards. So this is the identification piece. And remember, we saw in the regulations some of these things that might help us be able to identify our known or reasonably foreseeable hazards. So I already read through all of these. This is directly out of the regulation. I'm not going to read through them all again. I will say that the regulation doesn't say you have to write down that you thought about all of these. It's just meant to be a list of things to help you think about to identify your known or reasonably foreseeable hazards. Currently, right now, there is not a single list of known or reasonably foreseeable hazards for like different species or different feeds. We talked about a lot of them in chapter 3, and you're probably already aware of a lot of them. But there is some work being done through AAFCO, the American Association of Feed Control Officials, to help come up with a list of known or reasonably foreseeable hazards. So you could just take your intended species and use their list to say, okay, these are what's known or reasonably foreseeable for this particular species. So there is some work being done. Maybe by the time you're watching this recording, that is available to you. But that's something that you, at this point, kind of have to do your own legwork on. All right, so once we figured out what's known or reasonably foreseeable within our facility, now we need to do the assessment pieces. So the first assessment piece, the first evaluation piece, is severity. So just kind of asking ourselves, how sick is this animal going to get? Or is it going to cause illness in humans? And I think it's really helpful, and FSPCA, FDA is recommending that you as a company create some sort of rubric to help with this communication. Remember that even though we're all doing the legwork right now to set up this document, it's something that is intended to be used for years to come. So having that communication, kind of a level playing field with this communication, making sure that everyone's using the same language for years to come is definitely important. So here's an example of a scoring rubric for severity. I'm going to read these because this is what we're going to be using as our examples and you'll be using in your assignments for this class. So first is a high severity means imminent and immediate danger of death or severe illness likely to impact humans and animals. So even though we're making animal feed, that human component is still there and still very important. Number 2 is a medium. Danger and illness may be severe, but it is not imminent or immediate, likely to impact animals, possible to impact humans. Number 3, low. Illness or injury may occur, but impact is reversible, likely to impact animals, unlikely to impact humans. And number 4, very low. Illness or injury is minor, possible to impact animals, unlikely to impact humans. So this is what ABC Feed Mill and what ABC Pet Food has decided to use as their language for their severity score rubric. You are welcome to change this language however you see fit. So that's your business decision to decide what this language is going to look like. You are also welcome to use a different tier system. You don't have to use 4 rankings. I've seen companies use 3 rankings or 5 rankings. You don't have to use Roman numerals. You can use numbers or just descriptions. So tailor it to what makes sense to you. Or I've even seen companies take this directly out of this curriculum and use it, which is totally fine as well. As long as you have some language built for a scoring rubric, then you should be good to go. So once we figured out the severity, the next step is the probability. So I know if it's going to cause illness or injury. Now I need to know how likely it is to occur. And remember that our CGMP program plays a big role in this. If I have good CGMPs, the probability of hazards happening is lowered. Okay? But before I get there, I want to also recommend that you have a scoring rubric for probability as well. I again am going to read this one so you can kind of see the language that our examples are using. This time we're using letters. A is going to be high, immediate danger that the hazard will occur. B is medium, probably will occur in time if not corrected. C is low, possible to occur in time if not corrected. And D is very low, unlikely to occur, may assume that the hazard will not occur. Okay? So that's the language. Again, you can use what you want to use with that language in a tier system, whatever works for you. I've said a few times that the CGMP program can influence the probability factor and kind of raise or lower it depending on how good your prerequisite program is. That said, with our particularly high risk hazards, I'm thinking particularly about like salmonella or copper in sheep. Even if you've never had a problem with that, any FDA investigator is going to put those in at least a medium probability, if not a high, every time. And that might come down to personal preference and personal experience, but those things that we saw on the RFRs in Chapter 3 are going into these categories regardless of whether you have a good CGMP program or not. Same thing with severity. If they're causing illness and injury, that's got to be at least a medium, if not a high, every time. Okay, so how do I know? What kind of resources can I use to help me? Well, we just talked about the RFRs. We looked at the RFRs from a 5-year period that can help you figure out what's known or probable and what the severity is. FSPCA has some resources. FDA has a bunch more resources outside of the RFR. There's always a bunch more guidances being created all the time that can help you. CDC might have some information. If you're exporting or importing to the U.S., European Food Safety Authority or World Animal Health Information Database might be a good place to go. The AAFCO official publication has a bunch of good information in it that can help you with this stuff. The NRC nutrient requirements, feed additive compendium, peer-reviewed research publications, and trade association white papers. The other thing I might say is that especially pet food people, don't be afraid to go into the human food side of things to look for resources and information. A lot of what you guys are dealing with as far as the microbes kind of translates into the human food world, so you might find some more resources there. So don't be afraid to dip your toes on that side of the lake. Okay, so those are just a quick list of some resources to help us figure out probabilities and severities. Now, this next step is the actual determination. So this yes or no question. Do I need a preventive control or not? And to do that, what I need to do is bring together my severity and my probability evaluations. And so to do that, I'm going to recommend that you guys build something like this. This is a matrix that brings together our rubrics of severity across the top and probability across the side. So those are exactly the same rankings and same language that we just read. And now we bring them together and put them just like a multiplication table. I bring a high severity and a high probability into this box right here and give it a ranking of a 1A. So this is meant to be a place where you can take your list of known or reasonably foreseeable hazards and put each one of them somewhere on this table. Say, prevent or known or reasonably foreseeable hazard number 7 is a 4C. Okay, and then I know that it has a very low severity and a low probability. All right. The idea of setting it up this way is that the risk level goes down as we move to the bottom right-hand corner. So these ones up here are very high-risk situations. These ones down here are low-risk situations. So just from that description, you can probably already figure out that this end of our matrix here is going to be hazards that we're going to put preventive controls on, and everything else is going to be not, because it's a lower risk situation. Okay, so this is meant to get us to that yes or no answer, whether we need a preventive control or not. A couple examples of how we can use this. Here's one. In this situation, this company has a 3-tiered system. So what this is meant to represent is that these ones right here, these dark colored ones, are in the critical category. They're the really high risk situations. These 3 boxes, if any hazard falls into one of these 3 boxes, they are going to get a preventive control, no questions asked. This medium category right here, those are meant to be kind of case-by-case situations. So it's a moderate risk level, so case-by-case situation. And then anything that falls into here, into these boxes, is negligible. We can catch it with our CGMP program. We are not going to put a preventive control on those. Okay, another example. This company is a little more risk averse, so they're saying that anything that falls into these boxes is going to get a preventive control. Here's our case by case, and there is our flat nose. They're not going to get a preventive control. Okay, again, I highly recommend you build something like this, but you can totally modify it. We talked about doing 3 or 4 categories for these. You are welcome to do 3-tiered systems for your different colors and your yeses and nos and maybes. Or you can do a 2-tier system, so you can have just a yes and a no. That might kind of help things be a little bit clearer, and it doesn't leave quite as much room for flexibility or conversation, but it does make those decisions a little bit easier. I've also seen companies that have put numbers instead of Roman numerals or letters, and then they just multiply those numbers and come up with a table of numbers and say anything that is less than a 4 is getting a preventive control. Okay, so again, you can modify this to be whatever works for your facility, or you can take this one directly and use it. That's totally fine. So regardless of whether you come up with a yes or no answer, you're going to want to have some justification for why you came up with that answer. So this step number 5 is to justify your decision. So if you have a no answer, you're definitely going to want to have some justification there. If you have a yes answer, that justification is a little bit simpler, but this is a place where you can show an investigator that you thought thoroughly through all of these steps and that you made a good sound decision based on data and research and historical information. If you did have a yes and then you justified the yes, then you need to decide what type of preventive control you're going to put on that particular hazard. Okay, we have a few different options, and for your hazard analysis, all you need to put right now is the category it falls into and a quick description. So we'll look at an example at the end of the chapter of this, but I just want to remind you that this is not the place where we are describing this in detail. This is just a short sentence that says this is what it's going to be, and we're going to describe it later. So remember our options for preventive controls. Process controls is things that we are doing in our manufacturing and processing in our facility to control a hazard. Sanitation controls are going to control biological organisms through sanitizing food contact surfaces or even doing hygienic zoning programs. And then a supply chain applied control is where you're going to ask your supplier to control a hazard before it gets to your facility. I think of the example as like renderers selling their products salmonella free. That would be an example. We also have this category right here that's called other controls, and essentially that was built into the regulation for when you have something that doesn't fit nicely into the other categories. I have yet to see an example of this, but it is built in there just in case. I also need to tell you about some situations where you will not need to implement a preventive control. And I don't particularly like this language of the facility is not required to implement a preventive control because it sounds like they're not being required to control the hazard, but they still are. So let's look at some examples here. So this is particularly where an ingredient or raw material supplier doesn't need to implement a preventive control. And essentially what it boils down to is that you are asking your customer to control the hazard for you. So this is 50736. If this is something you're interested in, I would recommend going reading this part of the regulation. But essentially what it says is that you do not have to control a hazard in your facility if you have an agreement with your customer that says the agreement that the customer is going to control the hazard within their facility. And in order to do this, you need to make sure that you have assurances between your facilities that have that legal language in them that says the customer is going to control the hazard for you. Okay, so this is you rely on your customer to ensure the identified hazard will be significantly minimized or prevented by themselves or an entity further down the distribution chain. If you're going to do this, you need to disclose in documents accompanying the animal food that it is not processed to control the identified hazard. So it has not been processed to control salmonella. Something like that has to be on the label or on the slip going with the food. You also need to obtain those assurances that I was just talking about, and you need to do that annually. So every year you need to have signed documents with your customer that says that customer is controlling the hazard. And there was some language in the record keeping section about assurances, so make sure you review that as well. Okay, so that's 50736, customer controls a hazard for you. Okay, so now that we've done the evaluation, we figured out what preventive control we're going to use, the next step is to assign a preventive control number, which is essentially just an identification step. So like we would put a number on an SOP, we're going to put a number on a preventive control so that we can reference it and know which one we're talking about. All right, so those are the 8 steps of the hazard analysis process. I'm going to put this back into the original graphic of our different 3 buckets and kind of summarize all of that. So remember up here we had everything ever possible in the world. We ask ourselves, can it cause illness or injury? If it can, we call it a hazard. Then we put those into bucket number 2. And say, can this be associated with my facility or my type of animal food? If the answer is yes, then we call those known or reasonably foreseeable hazards. We take all those known or reasonably foreseeable hazards, we've put them into a nice list, but we also put them into our 3rd bucket, and we ask, how severe is it, and how probable is it? If it's a pretty high severity, high probability situation, a high risk situation, those get dumped out the bottom of that bucket, and we call them hazards requiring preventive controls. From there, we have a few options of how we're going to mitigate that hazard. First one is that we ask our supplier to do it for us. That's what we call a supply chain applied control. Second one is we do it ourselves. Those are called process controls or sanitation controls. Third option is our customer does it for us, as we saw in 21 CFR 507.36. Okay, that's the whole process summarized here. Now we're going to look at examples of how we write this down in the food safety plan. So first we're going to look at a blank example, and then we're going to look at a filled in example from our livestock and pet food examples. So this is a blank food safety plan. This is the hazard analysis section of a food safety plan as FDA sees it. So first up top, we have our good record keeping practices that we talked about in subpart F, identifying the plant and the date, that kind of stuff. Then we have the hazard analysis. The first step of hazard analysis was identification. So here in column number 1, I have a list of ingredients and steps or equipment within the process flow that I list out right here, our brainstorming session. Step number 2 was to identify the known or reasonably foreseeable hazards. And you'll notice I have them split up BCP. That stands for biological, chemical, and physical. That particular piece is not a requirement, but I think is good for communication and helps you kind of figure out how to deal with those. So this is your list. This is your list of all your known or reasonably foreseeable hazards within your facility. The next step will be to evaluate those hazards. So first I'm going to evaluate for severity. Next I will evaluate for probability. Then I'm going to bring those together and ask myself, does this need a preventive control? Yes or no? And then I'm going to justify it. Say why. Why do you think it needs a preventive control, or why do you think it does not need a preventive control? All right, so we've identified, we've evaluated. Now let's describe quickly our preventive control. So this is just a section where I can say process control, extruder temperature, for example, just a quick description of a preventive control. If you don't have a preventive control, you can just put NA in these categories. And then our identification, how we identify that preventive control. All right, let's look at an example. I think this will make a little bit more sense with some of this filled in. So this is ABC Feed Mill, our livestock feed, medicated and non-medicated feeds. So table number 1 is what we consider to be our hazard analysis table. Good record keeping stuff up top here. Column number 1, brainstorm session. Take a look at this right here. This just says ingredients in general. All of the ingredients, okay? What I have been told is that that's okay. If you want to just put all of your ingredients in one category, that's fine. What I think it makes more sense is a little bit more practical is to group your ingredients based on hazards that could be associated with them. So like you could put all of your proteins together and put all of your grains together. If you have an ingredient that is particularly high risk, I've seen a couple of companies do this where they have all of their ingredients in one box and then corn in the next box because that's where the hazards are coming in. Okay, so you get to decide how you want to categorize these things. And again, just make sure it makes sense for what you've got going on in your facility. We can see that the mixing processes or the manufacturing processes that they chose, hand addition of ingredients and mixing, they separated those out. That's again a place where you get to decide what categories you want to use here. From there, from that brainstorming session, our next step is to identify the known or reasonably foreseeable hazards, listing them out. These are the known or reasonably foreseeable hazards that could be associated with my ingredients. These are the known or reasonably foreseeable hazards that could be associated with hand addition of ingredients. And you'll notice that some of them show up twice in different places. And what I would encourage you to do as you're making this list in this column is to list out anything that could be introduced or the likelihood could be increased. Okay, so for copper toxicity, for example, we have copper toxicity associated with our ingredients because we're bringing premixes in or maybe even bringing copper in. So that can be introduced there. With hand addition of ingredients, the likelihood of copper toxicity happening gets increased in this section. So we're not necessarily bringing in something new, but if the hand addition doesn't go right, then copper toxicity could be a hazard in our final feed. Same thing with the mixing. If the mixing doesn't happen right, that could be a hazard that ends up in our final product. Okay, so think about, can it be introduced? Can the likelihood be increased? From there, we're going to grab a couple of these and carry them over into the next evaluation step. It's going to look like this. So salmonella, the severity, this food safety team decided the severity of salmonella was medium, and then they said the probability of it was very low. So they are not going to put a preventive control on it. And then take a look at their justification. So we've got an FDA guidance document, we've got a peer-reviewed study, and we have a statement number 1. Okay, great, but what does statement number 1 say? Let's take a look. So this is an example of statement number 1 that you could include in your food safety plan. Salmonella species is not a hazard requiring a preventive control in this facility because there are few types of salmonella that are concerns for the types of animals that my feed is intended. And then I have a list of all the serotypes I am actually concerned about. Then, those types that are a concern have been shown to not be prevalent with animal feed or ingredients. Thank you, Lee et al. Has that peer-reviewed study to back that up. Okay, great. That's a decent justification. Let's take a look at another example. I'm not going to read all of this, but what I do like about it is that this one teases out severity and probability separately and addresses them separately. I've had a few regulators in my classes and I've asked them which of these justification statements they like better, and I've gotten mixed answers. Some investigators like the shorter one because it saves time. Other investigators preferred this one because it has a little bit more details to it. So again, business decision for what you want to do for your statement number 1, but I think this is a good example of a justification statement that you can include in your hazard analysis. Okay, let me go back here and let's take a look at copper toxicity. So remember, we're feeding livestock, so we are feeding sheep. Severity is going to be high. Copper kills sheep. We know that. Probability is assessed as a medium, and so yes, we are going to put a preventive control in place. Justification: multi-species premix is used by the facility. Copper is toxic to sheep. Okay, great. Let's take a look at the stones and metal hazard that we have in the bottom category. Severity was very low, probability was medium, and they said no, they don't need a preventive control. And then take a look at this description right here. Grates employed over receiving pit, feed cleaner, magnets checked weekly for ferrous metal. That right there sounds to me a whole lot like a CGMP. And in fact, that's what it is. So this is an example where a CGMP can drive a decision to say, no, we don't need a preventive control because we've already got these things in place. Okay, so that's a CGMP preventing a preventive control. All right, let's go to the next section. So salmonella, we said no, we don't need a preventive control. Metals and stone was a no, but take a look at copper toxicity. We are actually going to have not 1, but 2 and 3 different preventive controls for copper toxicity. The first one is going to be a supply chain applied control, where the control of copper level in sheep mineral premix. So our supplier of the mineral premix is going to control the copper level in it for us. The number 2 is going to be a process control, procedures for ensuring correct manual weighing and addition of sheep mineral premix. And a third process control, procedures for mixing and sequencing of food for sheep. Okay, so you can notice that these are just very quick descriptions. We've got the category and a quick description of what they are, and then we label them to make sure we can identify them. Okay, cool. So that is table number 1. That is a hazard analysis table for this particular company. I want to show you one example of how these different factors can change based on different aspects or different things going on in different facilities. So this is going to compare facility number 1 and facility number 2. The hazard we're looking at is copper toxicity in sheep food. So we're going to assume that both of these facilities make sheep feed. So is it known or reasonably foreseeable within your facility? Both of them said yes. The severity is going to be high and high. They're both feeding sheep. Copper kills sheep. But take a look at the probability. Facility number 1 said their probability was low, and so they put a no decision. They're not going to have a preventive control. Facility number 2, their probability was medium, and so they had to say yes, they are going to put a preventive control in place. Take a look at the other information on this table and see if you can figure out why. Why was facility number 1 able to decrease the probability to a low category and not have a preventive control in place? There's two major things that you should have picked out. Number 1, facility number 1 only uses a single mineral premix, while facility number 2 uses multiple mineral premixes. So the likelihood of things getting mixed up in facility number 2 is much higher. The other big difference is automation versus manual weighing. Okay, so there's a human error factor in facility number 2 that could increase the probability. So these aren't even GMPs, but these are manufacturing processes, regular operating procedures that are driving this probability to be lower in a facility with automation and a single premix versus a facility using humans and other mineral premixes. Okay, facility number 2 is ABC feed mill, just FYI, that's the example that we're working with. So they are going to have a preventive control, and this is what it's going to look like. And of course, they're going to have their management components, which we'll explore in detail later. All right, so that's a little change in probability. We're going to take a look at a pet food example next and take a look at differences in severity after that. Okay, so this is ABC pet food. Remember, we're making dry extruded dog and cat food. Let's take a look at their table number 1. Again, brainstorm session to start. They also decided to group all of their ingredients together, and then they have their bulk receiving and their mixing as 2 separate processes. Again, up to you of how you want to categorize these things. Next most important step is to identify your known or reasonably foreseeable hazards, making that list. Here they are. You'll notice that these look a little different than our livestock ones. We've got that thiamine deficiency because now we're feeding cats. So our intended species is different. Our known or reasonably foreseeable hazards should be different. Let's carry a couple of those over. We've got salmonella. So salmonella was addressed at a high severity and a high probability. Remember that pet food is considered adulterated if there is any salmonella in it at all. Livestock food, we were concerned about specific serotypes. Pet food is any salmonella. Okay, so the probability of that is going to be medium to high. I mean, you're bringing in raw ingredients with salmonella in them. So they decided this is going to be a yes. Their justification was the salmonella document from FDA. All right, thiamine deficiency in cats. They assess this as a medium severity and a low probability. So even though thiamine deficiency is an issue in cats, this company is not going to put a preventive control on it. And then take a look at this right here. COA used by known supplier with historical data to confirm values. Okay, cool. Another CGMP that they already have in place with historical data that can help them justify a no decision, even on what we consider to be a little higher risk situation. Metal, though, let's take a look at their metal. 2 is a medium severity, medium probability, and yes, they are going to put a preventive control on it because the ingredients may include non-ferrous metal that may not be caught by a magnet. So it sounds like they already have a magnet in place in their CGMP program, but there's other metal fragments they need to be concerned about. So that's like a hole that has been identified in the CGMP program that they need to cover with a preventive control. All right, the columns 7 and 8, the preventive controls. For salmonella, we're going to do 2 of them. We're going to do extrusion temperature as a process control, and we're going to sanitize our post-extruder surface as a sanitation control. I always like to point out here that this doesn't just say extruder. It says extrusion temperature, okay? You should be that specific to say extrusion temperature is what's killing that salmonella. All right, metal process control, metal detection of finished pet foods to cover what that magnet is not getting. Identification in column 8. Great. Okay, so that's table number 1 for ABC pet food. Here's an example of differences in severity. So here we're talking about a metal hazard, and we're going to compare a livestock example to a pet example. So is a hazard known or reasonably foreseeable? Yes, absolutely. Almost every facility is going to be dealing with metal just because we have metal equipment that can possibly lose stuff. But the severities can be very different. So multi-species livestock example said the severity was very low, but dog and cat said the severity is a medium. They both had medium probabilities, but that drove a no answer for the livestock and a yes answer for the pet food, mostly because of the size and physiology of those animals. Okay, so differences in severity given different facilities. We saw an example of different probabilities given different facilities. All right, so let's summarize what we just talked about. I know it's a lot, but it's okay. As you work through the exercise, it should be a little bit clearer. The hazard analysis is the most important element of developing an effective food safety plan. Absolutely. Your justification should be built into this. It should be the foundation of your food safety plan. Hazard analysis includes identifying your hazards, evaluating those hazards for probability and severity, and determination of your control measures or mitigation strategies. Outside resources are absolutely critical for helping you do this, to help you identify and help you evaluate your hazards. Hazard analysis is specific to the product and the process and the facility that it's in. Okay, then here's exercise 5. Actually, that's my version of exercise 5. Here's FSPCA version of exercise 5. In this exercise, students are usually grouped together and given a fictional facility that they have to do a hazard analysis for. Please take a look at your assignment that's associated with this particular chapter to see what your requirements are for this exercise. Our last summary of exercise 5, there are specific regulatory requirements that must be completed during hazard analysis. However, there is flexibility in how to apply those requirements. The outcome of a hazard analysis may vary. Not all hazards will be evaluated the same or controlled the same, even within the same type of facility. And it's important to document your rationale or justification so you remember your thinking at the time and have alignment with your team and can support the scientific basis for decisions. Okay, good luck on that exercise, and I hope this was helpful for understanding the hazard analysis process.